Welcome guys to another video after some time now. And on this video, it's not gonna be okay, it's gonna be educational because not just to you guys, but to me as well. So I'm gonna be learning Akka and then I'm gonna be using .NET for learning. I'm a C sharp dude, so that's what I'm gonna be using. Anyway, not gonna be wasting time on something like this. So I'm gonna be explaining first why I have to learn this thing, or why am I learning this thing. And I'm gonna start by this thing. I'm at a point, I'm building an application and I have a problem of speed. So let me explain what is happening. Let me make an example using, let's say, a restaurant, right? So I'm gonna do this thing. This is my actor. Okay, I'm gonna be zooming. So this is my customer one, and we're just gonna do, and we do have a customer two here, right? So we do have our customers here, and consider adding another person here, and then we're gonna make this person our waiter, right? Remember something, for this waiter to process each and every order, they first have to go to this person first. Once they are done, if they are allowed to collect multiple orders at the same time before they go to the chef, they're gonna order whoever's preparing the meal, they're gonna have to come to this person after this one. And then once they're done, now they have to go to, let me create another one called the chef. Chef, right? So collects information here, then comes collects information here, takes orders to the chef. Chef provides the meal, takes this meal to this person or to this person first, and then comes back and provides this meal to this person, right? And then waits for another customer. Now this is the problem. Imagine now there's like about, let's say, many customers, right? You can just say customer three. Now the process becomes like a bit long because we'll have to go here, go here, go here, then go here. You see? So it's a problem. So the problem that I have is this with this person, right? So consider this person to be a thread. If you don't understand what a thread is, a thread considered to be more like a pipeline, or actually in this example, just a wait. And with an application, it's possible to operate using many threads, or in this example, we can have many waiters, right? Imagine now we have two. That means if this one goes to this one can go to this one. And then based on whoever finishes first, now they're gonna attend this one and then go this one. Since this one is being attended, this one will just go here and then wait for this one to finish, giving the order to the chef, and you get the logic, right? So basically, threads increases the speed of processing data or processing information. That's why I'm like, okay, in my application, I do have a lot of data that needs to be processed, right? And how can I do this thing? I think of threads, right? And then I'm like, okay, what is a thread? Let's start here. What is a thread? So we're gonna start by some basic thing and start an operating system. Yeah, let's see. What is thread in programming, right? Now let's start this. Come on, where am I? Oh. So now let's see. A thread is a small unit of execution within the process, allowing a program to perform multiple tasks. You get it? So now with these people, we can perform multiple tasks by collecting order at the same time. Look, multiple tasks concurrently at the same time. Concurrently, like at the same time. Despite that one, I've created a project here called study, on which I'm going to be using to study this thing, and you're going to be there with me. And I found out that in .NET, this is what we can use for my issue, right? And then they say that Akka.NET is a toolkit and runtime for building highly concurrent distributed and fault tolerant event driven applications, right? So I'm gonna be coming here. Hi, I am learning Akka for my project. Let's start with intro to Akka using C#. I think this is the best way to go about it. My thing is not paid, so we're gonna have a limit, right? Anyway, we're gonna have to move fast. That's why we need other resources so that we don't always ask this thing. Okay, so perfect. Let's dive in. We'll start with introduction to Akka, which implements okay, concepts. Now seems like communicate asynchronously via message. Okay, so now we're gonna be dealing with the concepts, core concepts. An actor model is a way of thinking about concurrency in distribution. Small independent unit of computation. This is what an actor is. So that means an actor is just a waiter. That means this waiter is gonna be doing one thing, and once they're done, when we're just collecting the order from this person, and it receives messages, processes them, and can send messages to the other actors. Chef is an actor. That means we take information from this customer, and then we pass the message to the chef, on which is the order. Each actor has a mailbox queue of incoming messages. Meaning, remember something, a waiter can operate multiple customers, meaning we're gonna take order and stack it, stack it, stack it, right? And then it receives messages, processes them, and can send messages to other actors. Each actor has a queue of incoming messages, meaning those messages are basically orders. A behavior, how it reacts to messages, meaning certain orders probably, I don't know, we're gonna be behaving in certain ways, but I don't think it's gonna happen in, I don't know, with a weight, a unique address where the actor is actually located. I think with the waiter is just gonna be on specific, how can I put it? The chef operates at the back, right? So that's the location of, and then the waiter operates straight within the customer's area. Anyway, so we have add package. This is how we're gonna be adding this thing, and then this is how we create an actor. We create a constructor, and then the constructor does have this. Okay, there's a receive function here that takes a function, and then specify the type of message that we expect to receive. And then we do have something called handle message, on which actor system. Okay, we do have something called system. Actor system create actor system. Actor system will create an environment where all actors live. Oh, that means an actor system consider it to be more of our shop here. Meaning, if we do have, if this is our shop, let's send to the back. To back. Consider this to be our shop. So this is our actor system, and system.actor creates instance of actor.tell sends an asynchronous tell. That means if or ever we were to say waiter.tell, that means basically saying customer gives the order to receive defines which type or what message type that the actors handle. That means this is the type that the type of message that the actor is expected to receive, right? Concurrency without pay, no logs, no shared state, the scalability. Okay, I think we can start with this thing. So I'm gonna do this. Len Akka. I'm gonna be Okay, so now let's do this intro. Let's create a console application to learn this thing. Intro to Akka, right? Now let's do this, and we're gonna be starting here. So we do have our thing here, our class program class here, and we need to create an actor. Remember something, with us we're gonna be using the example of a restaurant, on which, if you check here, we were using a restaurant or a shop basically, and our actors are gonna be a waiter and what else, our remember something, customers at this point are not actors, since they're the ones that provide information. We don't have to actually create. We are operating at the restaurant level, right? So we get information from where? From their customers. We're not going to be including them and creating actors. So now, if we were to start this thing, we're going to be creating an actor, and then our actor is going to be a waiter. Waiter, and we forgot to do something here. So we need to add, manage this thing. I think it's Akka. And install. Okay, we're done. And now let's check something here. We need to know how to create an act. So the syntax is this: public class hello receive act. Okay, so that's how we do this thing. Inherits receive act, and it's just gonna have this using Akka act. All right, and then with the constructor we do have receive, and then we have to specify the type on which we're just going to be making it, and then we do have a function on which the function calls the message, on which the message that we're going to be getting. And wait a minute, let me see what do that. So they expect a function that takes string, right? Registers and handles incoming messages. The handler should return true if it has handled the message. If the handler returns true, no more handlers. No more handlers. No, the handlers registered. Okay. How many are they? So there's an action. This is a handler. Predicate should handle. So the one that we're gonna be using seems to be this one, where we take it's an action, we take it and handle that thing. Right. So message. Right, and with this message, what are we gonna be doing? We're gonna be let's create a handler here. So private void handle message. I don't know. It seems so. Seems like to be the. So we're just gonna say handle message and message. So with this message, we're just gonna say handling message. Message. Think. So this one has to be named static, and that's it. Now we've managed to create our waiter here. Actually, instead of calling this the message, let's make it an order, and handle order, obviously. Handle order. Let's make handle customer order. Handle order. Because I'm thinking also the waiter, I mean the chef can provide it. Okay, but actually at this point, let's just handle custom order. right? And customer handling customer order. Okay, received order. So I think this one makes sense at this point. So we do have handle customer order, and so what's gonna happen? We do have an actor, waiter, and then with this waiter expects to receive a message, and the type of message that the actor actually expects to receive is a string, is of type string, right? Meaning message based text. And we do have a function within what, within the waiter actor, right, to handle the order. And then the process of handling order, what we do is just to print received order, and then we specify the order that we received. No problem. Remember something: every order, every actor to exist, they must exist within actor system. Let's check here. Where is it? Dun, 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 dun. Where, okay, creates environment where all actors live, meaning, yeah, that's where. So the syntax is you have to be using so that you can actually expose this thing. So system variable system actor system dot create. All right, now let's do it using a variable system. Okay, our system is gonna be called a restaurant or a shop. Let's just call it a shop. So variable shop is equals to new actor. Actor system, is it actor system? Is it actor system? I think it's an act. Is it do we create it's actor dot system actor? Come on, how do we write it? Actor system. Yeah, it's actor system. Is it? No. So it's a actor system. So this thing is it an abstract class? Let's go. Is static? Is it static? It's an abstract class. Yep, it's an abstract class, and then actor runs factory, and then we do have name. We do have a lot of properties in there, and functions. Actor dot. Do we say create? So now we need to. We're just gonna call it shop. That's the name of our actor system, basically. Yeah. And with that, what we're gonna be doing now, we're gonna be creating our actors. Since we do have our actor system, we need to create our actor. So our actor is gonna be what? Is gonna be waiter, one which is gonna be shop dot actor of. So actor of. So this thing, that's how they created. Wait, let me check something. So actor, on which actor of. So let's read this thing. Actor system dot actor of the name. Okay, the type of the actor and hello actor, and then the name of the actor here. Okay. Actor of waiter, and we need to. Is it necessary though? Let's just provide the name of the actor. I'll just say waiter, and then with that, we use capital letters, and then with waiter to tell, we're gonna say this is basically this code. This line that I'm writing is basically like a customer telling an actor what to do at the order, right? So I can say so let's say cheeseburger, right? This is our bed. This is what we are doing. So we created an actor here called received order. So let's run this thing. See if it will work. So you can see received order cheeseburger. So that's the order that we actually received. And okay, now I feel like we are good. So that's the first part about this whole thing. So we do understand how to create an actor. We can tell, receive, Akka, currency. Okay, no problem. So it seems like we actually get introduction to Akka. And we can actually now do some advanced things, right? Let's ask this dude. Let's dive into some advanced features. Let's escalate this whole thing and see if we can actually get it. So we do have something called actor hierarchy supervision, hierarchies and supervision. In Akka, every actor except the root has a parent, which makes up a supervision tree. So everything is in the form of like, okay, let's see. I think I saw something here. Actor system. This is it. So we do have a root, kids, root to these kids, parent. So a parent to these kids, and error canal. That means supervision and monitoring. Is it the part that we are act? Probably. I don't know. So okay. So we do have a child actor. So message is supposed to fail throw an exception. So pre-start console child started, child stopped. So they do have some functions on which we can override here. Parent actor, untyped actor. So okay, this is another type of an actor. So there's a receive actor and untyped actor. Okay, and I actor reference which small child to drop parent actor. I actor reference is equals to child. Now I see. Child is equals to context dot actor of child actor, which is this one. So specifying the actor inside of this actor, and then we're gonna name it the child. On receive. Now you're saying on receive. On receive, we're getting an object, which is a message, doesn't type. And if message is string, message, child or tell, message, since this one receives a message string, right? And from the parent supervisor strategy, we're overriding supervisor strategy. New one for one strategy. Makes number of retries 10. Within time range. That means we're gonna have max number of retries. Locally only design. Directive. But restart. Supervisor defines how parent handles child exceptions. So supervisor strategy, what happens is that we define how parent handles child exceptions. Directive dot restart the actor. State is lost. Restart the actor. State is lost unless persistent. Meaning the state, if there's a state of the child, we're gonna be losing the state. Think so? Because we're gonna be restarting. Anyway, you can also stop, resume, or escalate. So directive dot restart. So that means directive we can stop, resume, or escalate. handling state safely, counteract. So the person, okay. So this one allows us to tell the parent the count that we had before with crash. Actor processes message one at a time. Count stays consistent even under heavy concurrency. Ask pattern. This one handles state safely. So we can now send. So within so we do have send. Okay, wait. Let me check something here. So from this thing, do we have something called, do we have, what is a sender? What is a send? Oh, inside the receive. Inside the receive, we do have something called send. Let me just do this. Do you have sender? Do you have something called sender? Okay, sender gets the sending actor reference of the current message, where the message actually comes from, right? Makes sense. And ask pattern, counter, counter, dot ask int get. So remember something, there's a tell and there's a ask. Ask pattern. What is ask? So ask meaning ask receives data. This one's on data on which ask allows us to do that thing. Meaning if we come here and instead of saying wait dot tell, let's say tell, let's see what it does. So it delivers a message. Okay, ask wait, come on, give me something. You see, it's an awaitable thing that returns an object, right? Which is makes sense anyway. Okay, that's how we so we can tell, we can ask. Makes sense. Akka remote actors. Let's you run actors on different machines or processes and still communicate as if they were local. Different machines, remote. So this is how you're gonna be connecting. Nice. And remote system. This is how. So actor select akka.ccp. Actor selection system. Actor selection. So now we're gonna be trying to connect to this person. Okay, persistent Akka persistent. For actors that need to remember their state even after restart or crashes. On recap. Akka cluster distribute this. Once you understand remote actors, Akka cluster takes it to the next level. So remember something, they run on different processes or computers on different networks, something like that. And distributed systems, then Akka streams for high throughput data processing. Akka streams provide reactive streams API built on actors. Example, using system, create our system, using materializer, and I don't know, variable source from, so there's a list. Okay, this is our source. Oh, it's a stream. So a stream is just a flow of, okay. And we do have a sync for each sync console data land. So this one just prints data, outputs things. So sync outputs await source dot select. So select meaning we are take from the source, we translate data on which what we're actually doing is we are changing the date. This process stream actor hierarchies. Parents, somewhat of what you've learned. Ask pattern, remote actor, request response communication, persistence, clustering and streams. So it seems like the one that is going to be more interesting. Remember something, the issue that we're trying to solve is that we're going to be getting data from somewhere and then we're trying to process that data. So we do have stream. So we do have our source on which is this one. And then from this source we select. That means we actually transform that to a specific form. And then we run with, meaning run with. Okay, now let's just dive into streams. Because I feel like streams are going to be the one that are going to interesting, right? Excellent choice. 30 minutes. Excellent choice. Akka streams is one of the most powerful parts of Akka.net. It gives you a reactive, high-performance way to process streams of data using Atom, but without having to manage the actor yourself. Okay, streams of data, flow of. Okay, what is Akka streams? Data flows. Data flows. It moves from one point to this. Much like link, but asynchronous, back pressured and distributed system. Each stream has three main components: source, products, data, on which maybe our database, and then the flow transforms data. So any part where we transform data is being called a flow. Sync consumes data, meaning we do something with that data at the end. Can be printing. That's why here they said this was the sync on which we're printing. It's just the end, right? To get the form graph that Akka executes efficiently. So we need streams now. So we're gonna come here, do this. We're gonna be doing streams. Okay. Streams. Apply. Okay. We're done with streams. Now let's see how they actually operate things. We done, create minimal, stream completed. We're using views. Okay, we need something. Use what is a materialize? We need what is a materialize for each. This is a flow because we're transforming data, and then we're saying that means that's the end where we write source, flow, sync, print. Simple. Parallelism with async boundary sync. So we need a flow create. Flow to create. Async bound flow to creating. This is a flow. And then expects an integer and then transforms it. This one multiplies by 2. This one plus 1. Sources from I-enable range via flow number 1 via flow 2. This is our flows. We via, that means connects the flows. Okay. Run with sync dot for each. Run with two things. Function to run with. Maybe it's the one that actually run with starts the flow. Can match the broadcast streams. So we do have two sources, and the source combines source 1, source 2, on which basically it's just it's like one huge source, and then the new match string matched run with say letters.zip. Okay, so there's match two source combining streams. Okay. All right, so we combine match. What is match? This is a broadcast custom graphs. Okay, so we have match or slash zip recover handle streams failures. Do you see anything? Error handling or select is, so when we transform we can actually now try to do recover, because obviously some, especially when it comes to 0, it's gonna throw an exception, and then we need to actually handle it here and return -1 fallback fail. I think it's quite makes that one. Okay, what is materialize? What is materialize? When you define your stream using source flow sync, you're actually building a blueprint, the description of the stream. So it's like, okay, blueprint makes sense. The blueprint does nothing until you materialize it. Materialize is the component that takes the blueprint and turns into a running stream of vectors. So basically, it's like putting things together. The materialize is the one that actually starts that thing, like start to push those things in. Okay, think of it like a source flow to materialize the engine that runs the pipeline. Once materialized, the stream becomes a live network of actors. Now you can actually see the movement once being materialized. So you need this thing, materialize, to actually operate this blueprint. So, and why materialized value? Sync, sequencing, int, collects all into a sequence and run with, let's play with this one. So we do know ask, so we're just gonna be keeping that one, and our act, we don't need this. All right, so we're gonna be touching the streams. So this is gonna be the last part, and now let's go. How do we start? Okay, it's getting late already. Let's do this thing. We need a materialize, right? As they say. As variable using, so that we can display this thing of running. New shop dot, is it? Not new, but shop dot materialize. So this is how we, let's see, let's verify. So from the actor, we system dot materialize, actor materialize, all the code may use, or all the code. Now let's do this. So with that, so we're gonna start with the source, right? So our source, let's just create something. Let's create a list. We're just gonna say orders, customer orders. We're gonna be processing them. It's gonna be no. Let's say cheese burger. Okay. What? Let's say chips. Hot dog. What is the last one? The last one could be let's say quota, right? And with that, so now we need to create a source. Source is equals to, so we need to create a source. So the source, how do we create a source? Do we say source using source dot from customers? So this is how we create a source. That means we are specifying the blueprint. So you're seeing the source is just going to be from the customers. That's what we're going to be using also. And then our stream. And remember something, stream is where we actually, not a stream, a flow. A flow is where we transform data, right? So we're going to transform data so that they actually change it. We want something like this. We want something like cheese bag. We want to do something like this and then be like cheese burger. Just for now, I don't think. And then number 2 is just gonna be chips and so on, right? So add order number. Okay, we can just say, yep, I think this looks good. Number 2, we can just say order number 1 and then order number 2, so you get the thing, right? Flow. So order flow, order naming flow. So we're gonna say order naming flow, which this is what we're gonna be doing. We're gonna be taking each and every order from the source, meaning from we're gonna be taking things from the source, right? So dot, how do we do the flow? Do we run? So now we have to say we do have an option of select, on which what we're going to be selecting. We're going to be selecting an order, and we're going to be transferring, we're going to be receiving an order, and you're going to be transferring it into order. What is it? Oh, okay, so it's going to be order number. Is it possible to get an index? See something. Select. Or should we create a separate function? Because I don't think this one will. Let's create a private function here. That will actually do that thing. So we create a function that returns a string, and what are we gonna name it? Let's say name order flow, right? And then obviously it's gonna be order, and we're gonna be retaining order number, so this one has to, let's see, order number starts with 1, order number plus Is it plus plus here when we don't want? This is how we do it, right? So order number plus plus, and we're gonna say just order, right? That's what we're gonna be doing. And let's make it static. Since, and instead of doing this, we're just gonna say name order. So now there will be the order flow, and then our sync variable print orders. Print order sync. So remove something. Let's see this. Source string. So can we do select? Wait, let me see something. Flow. That means order name your flow dot sync. Come on, how do we write sync? I was trying to cram that thing. So we say sync. Now let me look at this. Sync dot for each source form. Wait, how do we do the thing of flow? Create flow. Select for each. Dot for each. Oh, dot for each. So sync. This is okay. Print order sync. So we do sync dot for each. We're just gonna remake it. So what we're gonna be doing, we're gonna order, and we're just gonna be doing CW for order for each. Does it want something? For each expected. Okay, what is happening here? Okay, so we just string, and with that, now we're gonna be moving to the part where we actually start this thing. So to start this thing, we need what? We need run with. Well, which is it? The system? Do we say shop dot run with, or how do we run? Sync for B from nap. D not run with the source. Okay, source. So from the source. So we say customer orders in which we're gonna say source the run with perfect. So we'll connect this to a sync and run it. So what does it want? Sync. Okay, because remember something, we added this flow into the source, and then now we are saying it's gonna do the source number one. So print order sync and materializer on which is the materializer that we do have. So now let's run this thing. Hopefully it does make sense. So cheeseburger, chips, hot dog, and cod. I think it just wait, didn't select. Okay, maybe I'm missing something here. Run the flow, select run the flows. I want this one where we do source via flow. Damn it. So here we're not using any flow, so you can say via and then via. So via what? Via order naming flow, and obviously string. No, I thought I was good. Via. What am I missing here? Let's see, via transforms this source appending the given process in step. Is it a list of string? I don't know. Wait, via type. The materializer value of source. Type of output, type of materializer. Okay, type 2 and type of materializer. Do we say materializer? I don't know if item materialize. What is this? The type is equal to item materialize. Is it? And order flow naming. Select. Cannot convert from Akka DL. What does this? Wait, act. Wait, is it not? I'm getting confused a bit. Okay. Ordering. Okay, let's see. Floater create, right? Oh, okay. I need to create the flow. Okay. Wait. Okay. Flow dot create string must return something. Create dot select. What is the name? Name order. Name order. And because I don't want this thing. Yep. Somehow it worked. Let's see. Oh yeah. So we need something that was going to keep the state. Wait, and it does. Wait a minute. Let's see. What a one. What a one. What a one. What a one. Dun, 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 dun. Let's just int order number. What? What am I doing here? And instead of making this static, static, is it? No. Okay. Static. Let's name this. So I think it's good this way. Let's see. What a 1, 2, 3, 4. What a order, and we were actually not saying the actual order. So that's what happens. So order number 1, cheeseburger. Order number 2, hot dog. 3, you get the flow. So it seems like we are getting there. So if we know how to create flows, meaning we know how to actually transform data, so we get data from a specific source, we create a flow in which we change that into a specific, and then we sync on which we take data out of the thing we write or we do output, whatever that. So I think that's what that's where we're gonna be ending this video. So like it's quite interesting, you know. Imagine taking data from the database. Seems like the next part of this thing we'll have to actually implement. Because one thing that I wanted is this, right? So now we know how to actually take data from the source, transform it, which is good. And now the second part is this: how to make how to handle. Do we need process? Do you need a flow? Because with the flow converts that into a specific thing, and then with flows we can do it. Okay. How to create multiple flows for concurrency, something like that. But I think it will understand what I'm trying to say. Excellent. That's one of the most powerful things. Let's dive into multiple concurrent flows that process data in parallel, which is what we want. First, what are you actually doing? When you run multiple flows concurrently, you're building parallel data pipeline. Sequential flows, the sequential flows async. Source, then select, then return. What happens? Flow 1, flow 2, sync and run in parallel, and flow. Select async. Select async. That means, oh look. So this is all we have to do. Just change select async. That's it. Using GraphQL. Wait. If you want to run multiple flows side by side, e.g., two different processing pipelines from the same source, broadcast is what to do. Source, flow 1, broadcast. Okay, we will start with the first one. Parallel process with select. That's number one. So we can. So now let's actually add something here. Before we return this thing, let's do something. We're gonna do an await, and we're gonna say task.delay, right? And let's make it returns, right? Run with print order sync for each async. I think there is async. Wait, async. Wait, before that, let me do this. Shit, I don't know how to. To be honest, I don't know if. Anyway, let's just forget about this because I was trying to simulate. Oh, I see. I know why. It's because this thing returns it's a task. So you see this print, this flow. Task. Let's select async. What was I supposed? I'm playing a very guess. Okay, let's see. Select async. What? How many arguments does it take? Select flow. Integer. Okay, let's do it. So select async forces parallelism and select marker. Okay, so that means we need to select async. We can take two at a time and name order flow. And we're just gonna do this async. Damn it. Async. And with that, we need that await. Does the delay about for 10,000. Let's just do it like this. Now let's run. Let's see. Nothing has been. Wait. Mm. Let's remove this, even though it will try, but oh, wait, let's just see. So when I do the weight, okay, let's make it 10,000. Let's make it 1,000. You see, still nothing. Dun, 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 dun. Let's ask. Why doesn't it print? Okay, we don't await. So this thing is awaitable. Source.file. Wait, well, so await. Oh, it's awaitable. Oh. It's gonna work. Still, even if I wait this nonsense, still does the thing. Does not the right line, all others been processed. Oh, we ended up printing. Okay, let's look. Now, we should be printing things. So we process two at the same time, you can say. It's because we are running with two threads in two threads. We use two threads, then we're done. See here, so we are running using two threads. Okay. That's good. So I think that's pretty much it for getting to started with Akka, understanding the basics of Akka. I can't say I understand everything, but I think I have a clue of how it actually works. So yeah, that's it until the next study. So what are we gonna be do? Maybe use an actual application. Maybe create simple. I'm a Blazor dude, so I'm gonna probably create a Blazor application and try to work with it, like create database, fetch data, or we can even simulate data fetch, data fetching or something like that, and do some delays there and there, and use yield for database so that we can receive one. I don't know. I'm not so sure. We'll see. Otherwise, until the next one.